A quantum particle is subjected to potential defined as. Now, the question is asking ground state wave function of the particle is proportional to. Solving such type of question, we just have to focus on the boundary condition, and boundary condition for this problem is V for psi x plus minus a by 2 psi must be 0. So if we select this wave function and apply, let us apply psi x is equals to a by 2 on this wave function. So what do we get it? We get it cos pi by 2 into a by 2. Denominator a, so we would be having cos pi by 4. That means this wave function cannot be our answer. So our option would be cos pi x by a. Now let us substitute x is equals to plus minus a by 2. Cos pi by a, x is equals to plus minus a by 2. In that case we would be having it cos plus minus pi by 2, and that would be 0. Now you would be asking it one question, why I started with cos term not sin term. So you can write it down this condition for symmetric potentials. V of x is equals to V of minus x. Ground state wave function is always even. That means I can select only cos term, not the sin one. Let A and a dagger respectively denote the lowering and raising operator of a one-dimensional simple harmonic oscillator. Now let n be the energy eigenstate of simple harmonic oscillator. Given that n is an eigenstate of this corresponding to an eigenvalue. So in this problem we have to determine the eigenvalue corresponding to this operator when operated on n. And question is saying this n is an eigenstate of this. So in the end we would be having it n. So we have to determine any eigenvalue lambda. Now we all know A operated on n would give us root n into n minus 1. So when A operated on n, we got root n into n minus 1. Now we operated again A on n cap, so we get root over n into n minus 1, and here result will be n minus 2. Now we operate a dagger into on n. A dagger when operated on n would give us root n plus 1 into state n plus 1. So when we operated a dagger on n minus 2, we get root over n minus 2 plus 1 into state n minus 2 plus 1. That means we would be having root over n minus 1 into state n minus 1. So when we operated here n into n minus 1, we got a dagger n minus 2, and that gives us root n into n minus 1 into root n minus 1 into state n minus 1. That means a dagger n state is equals to root n into n minus 1 to n minus 1. Now we operated a dagger a on n. Here, if we operated a dagger on n minus 1, we would get the result root over n minus 1 plus 1 into n minus 1 plus 1. That means root n into state n. So I can simply write it down, n minus 1 root n into a dagger n minus 1, which give me result n minus 1 root n into state n, and this term is equals to nothing but what? N minus 1 into n or n. So I can write it down here, a dagger a state n is equals to n into n minus 1 state n. So option A is our answer. In this problem, S6 denotes the spin operator matrix, and spin matrix corresponding to S6 is given. Now the question is saying which of the following statement is correct. First, eigenvector corresponding to S6 are 1 0 0 1. In second option, the question is saying the eigenvectors of S6 are 1 by root 2 minus 1 or 1 by root 2 1 for both of state. In third state, any arbitrary spin states I is given. Now the question is saying upon measurement of x6, finding the probability of finding the particle in a state up is 1 by 4, or similarly for the same question the probability would be 2 plus root 3 by 4. Now let us write it down the matrix. S6 is equals to H cross by 2 0 1 1 0. Now the eigenvalue and their corresponding eigenvector for spin matrix S6R. Eigenvalues, eigenvectors for S6 is equals to plus H cross by 2 eigenstate phi 1 or phi I would be writing up would be 1 by root 2 1 comma 1. S6 is equals to minus H cross by 2 phi down state would be 1 by root 2 1 minus 1. Now psi for the given problem according to the question is one by root 2 in the bracket, it is 1 by 2 1 root 3. Now so we can express state psi as a linear combination of state phi up plus b phi down state. That means 1 by 2 1 by root 3 or 1 over root 3 can be represented a by root 2 1 1 plus b by root 2 1 minus 1. That means we are having it a plus b by root 2 is equals to 1 by 2 and a minus b by root 2 is equals to root 3 by 2. We have to determine the value of a. So from here we can write it down. A plus b is equals to 1 by root 2. A minus b is equals to root 3 by root 2. So 2a is equals to root 3 plus 1 by root 2 and a is equals to 1 by 2 root 2 root 3 plus 1. Now, so probability finding the particle in spin up state is P up is phi up that means mod of a square, that means 1 by 8 into 3 plus 1 plus 2 root 3, that means 2 plus root 3 by 4. So this is our correct answer, option D. A particle A with angular momentum 3 by 2 decays into two particles B and C, angular momentum J1 and J2 respectively. If 3 by 2, if this condition is satisfied, now 3 by 2 is a singlet state. 1 1 in the addition of angular momenta having values J1 and J2 for singlet state, wave function is represented by so this corresponds to this addition of angular momenta and particularly Clebsch-Gordon coefficient, where we write the wave functions of particles. Since it is a singlet state, our wave function would simply be 1 1 covariant 1 by 2 and 1 by 2. So value of alpha, if we compare the value of alpha from both these equations, we would get 1. Radial wave function of a particle in central potential is given, that is R r is equals to a r by a e की power minus r by 2a, where a is the normalization constant and a is a positive constant in suitable dimension. Gamma is the most probable distance of the particle from the force center. So most probable distance according to the question is Rmp is gamma A. We have to determine the value of gamma. Now probability density, radial probability density would be given by mod r of r square into dr. So here we would be getting it, or we would have it, a square by a square r square e की power minus r by a into r square dr. That means I would be having it a square by a square r की power 4 e की power minus r by a into dr. So PR is nothing but a square by a square power 4 e की power minus r by a. Now most probable distance would be given by del p by del r must be equals to 0. That means del by del r a square by a square into r की power 4 e की power minus r by a must be equals to 0, or we would be having 4r cube e की power minus r by a minus r की power 4 by a e की power minus r by a is equals to 0, or this implies we can take r cube e की power minus r by a outside. We would be having 4 minus r by a equals to 0. Now r cube e की power minus r by a cannot be equals to 0 as it makes wave function 0, but sign is otherwise non-zero. So 4 minus r by a is equals to 0 implies most probable distance is 4a. So gamma value of gamma is 4. A free particle of mass m is located in three-dimensional cubic potential with penetrable balls. The degeneracy of the fifth excited state of the particle. Now, for a particle in 3D box, its energy is given by Enx, Eny, Enz is equals to pi square h square by twice ma square nx square plus ny square plus nz square. Now we wanted to have the distribution of energy levels for different values of n. Now when nx take values 1, 1, 1, energy will be 3 E0, where I have defined writing like nx square ny square plus nz square is equals to E0, and E0 is defined as nothing but pi square h square by twice m e square. Now, so next state would be 2, 1, 1. So if next state would be 2, 1, 1, then energy corresponding to this state would be 6 E0, and eigenstate would be having 1, 2, 1 and 1, 1, 2. That means 3. Degeneracy of the first excited state is 3. Now next state would be second excited state would be what? 2, to 1. In this state, energy will be 9E0. So this state would again be having degeneracy 3. Next state would be 3, 1, 1. So in this state energy would be 11E0. That would be third excited state. And degeneracy of this state would be again 3. Now fourth excited state would be 2, 2, 2. That means energy will 12E0. Degeneracy of this state would be 1. Next state would be 1, 2, 3. And energy in this state would be 14E0. So for fifth excited state, energy is 14E0 and its excited states are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So degeneracy of fifth excited state is 6. Degeneracy in fifth excited state is 6. So in this question we have been given Hamiltonian H0 and H dash. H0 for H0 matrix is this, and for perturbation matrix is given this. Now question is saying maximum eigenvalue of H. That means H would be defined as H0 plus H dash, and this value is eigenvalue corresponding to H is 3 EV. Now the question, the value of K, round off it EV. We have to determine what is the value of K. Further, eigenvalue corresponding to H0 is also not given. E0 is equals to 2 EV. So we have to determine eigenvalue corresponding to H dash. So we have to determine corresponding to H dash. Now, so H dash matrix is defined as 0, K, 0, K, 0, K, 0, K, 0. Its eigenvalues are determined from circular equation. That is H minus lambda I is equals to 0 implies minus lambda K 0 K minus lambda K 0 K minus lambda equals to 0 implies minus lambda into lambda square minus K square plus lambda K square is equals to 0, or lambda into minus lambda square plus K square plus K square is equals to 0. So lambda is having value 0 into lambda is equals to minus lambda square plus 2k square equals to 0. So lambda is having value plus minus 1 by root 2k. Now, so maximum eigenvalues will be for corresponding to H has maximum value only when H dash is having maximum energy. That means energy corresponding to H dash E dash should be 1 by root. Oh, here I have right. So would be root 2k. So the energy corresponding to H is E is equals to E0 plus E dash implies 3 EV is equals to TeV plus root 2k. K is implies as 1 by root 2. Equals to 07.07. A hydrogen atom is in orbital angular state L and M is equals to L. Normally, orbital state of an electron in H atom is represented by L and M. If L lies a cone which makes half angle 30 degree with respect to the Z axis. If that is L and that is Z, now this angle according to question is phi is equals to 30 degree. So from the figure we can say it Lj by L is nothing but equals to cos phi, implies Lz is having expectation value ml h cross and this L is having h cross root over L into L plus 1. Cos 30 degree is, so this term is equals to, according to question M is equals to L, so we would be having L plus 1 is equals to root 3 by 2. Squaring the whole term, we would be having L square into L plus 1 divided by 3 by 4 implies 4L square is equals to 3 into L plus 1. That means 4L square is equals to 3L square plus L. That means 4L square minus 3L square is equals to 3L implies L square is equals to 3L 3. Thus our answer is L is equals to 3. In this problem, an electron in hydrogen atom is in a state N is equals to 3, L is equals to 2, M is equals to minus 2 is given. Now Ly denotes the pi component of angular momentum operator. Question is asking uncertainty in Ly. Now uncertainty in Ly is defined as Ly square minus Ly square. So that is the case. States we are having it n is equals to 3, L is equals to 2, M is equals to minus 2. Ly is defined as, in general, L plus minus L minus by 2, where L plus minus over state Lm is defined as H cross L minus plus M, L plus minus M plus 1, L into M plus minus 1. So if we determine L plus minus expectation value of L plus minus, that means Lm for any state, L plus minus into Lm would give us H cross root over L minus plus M into L plus minus M plus 1 into L M into L plus M plus minus 1. Since both these states are orthogonal, that means this term is 0, which means expectation value of Ly is also 0. So, but expectation value of L square y would be given by L square minus Lz square by 1 by 2. L 1 by 2, now L square would be H square into L plus 1, and Lz would be ml H cross square, that would give us 1 by 2 H square into L plus 1 minus ml square. Substituting the value of L and M, 1 by 2 H cross square, 2 into 2 plus 1 minus of minus 2 square would give us 1 by 2 H cross square, 6 minus 4, 2 H cross square divided by 2 is equals to H cross square. That comparing, so delta Ly square is equals to Ly square minus Ly square is equals to H cross square minus 0 equals to H cross square. Comparing with delta Ly square is equals to alpha H cross square, we get alpha is equals to 1.